All right, another example here. Researcher claims the stomachs of blue crabs from location A contain more fish than the stomachs of blue crabs from location B. They analyze content sample of 15 blue crabs from A, and they get a certain mean there, and a certain standard deviation. Then they analyze 8 blue crabs from location B, and a mean of something and a standard deviation of something, and at alpha equals 0.05, so 5% significance. Can you support the researcher's claim? Assume the population variances are equal. Okay. Now, technically speaking, we should also know whether or not these populations are normally distributed, because these sample sizes are certainly not big enough. So in order to do this problem, let's go ahead and assume the populations here are normally distributed, because technically they didn't say that, but let's go ahead and assume that. All right, so let's pull out some information here. Okay, so we'll let mu A be the that'll be from location A, and let's let mu B equal from location B. So, concerning the stomach contents. All right, so the mean stomach content in A, they said, was 191, and with a standard deviation of 38, and that had a sample size, we'll say NA is 15. You could have called these 1 and 2, I just called them A and B. And the mean for B was 180, and standard deviation of 42, and the size of the sample there was 8, and let's see what we have. Okay, so we want to set up our hypothesis test. Oh, let's go back. Researcher claims the stomachs of the location A ones contain more fish than the B ones. So mu A greater than mu B. All right, mu A greater than mu B has to go in the alternative because it doesn't have an equals, and that's the claim. Hence, mu A less than or equal to mu B would be the null. Because we have mu A greater than mu B in the alternative, that's a right tail. And we were told that the population variances here are equal. So let's say we put all that information along with the population variances being equal, and we calculated our test statistic t, and we got a p-value, and that's our p-value. So we got 0.265 as our p-value, and we want to compare that to 0.05, which was our alpha. Oh, that 0.265 is definitely bigger than 0.05. So with our p bigger than alpha, this is a fail to reject H0. Okay, so again, we're looking at the claim being in the alternative. We're in support mode. So our decision is either going to be that we have enough evidence to support the claim or we don't. Well, let's see what happened. We failed to reject H0. We were not able to bring ourselves to the alternative. So there is not enough evidence at 5% significance level to support the claim. specifically the claim that the location A crabs had more fish in their stomachs than the location B crabs. So not enough evidence to support the claim in this case.